Hi, everybody. Let's do IXL 8th grade E7 checkpoint scientific notation. Select all of the true statements. Let's look at the first one. 8 times 10 to the negative third is 200 times as much as 4 times 10 to the negative fifth. Is that a true statement? Well, let me start this off by doing another example using easier numbers, because sometimes just looking at the scientific notation is confusing. So what if I asked you to tell me if this was a true statement? 12 is 3 times as much as 4. Is that a true statement? Well, how would you figure that out? What you would do is you probably know that this is a true statement, and you probably figured it out in your head so quickly that you didn't even realize what you were doing. But in your head, what you probably did was you took this number 12 and you divided it by this number 4. So 12 divided by 4 is equal to 3, which means that 12 is 3 times as much as 4, right? 4 times 3 is 12. So that's the strategy that we're going to use for these over here. If it's asking you, is this many times as much as this, then what you need to do is take this number and divide it by this number. So let's do that. So 8 times 10 to the negative third divided by 4 times 10 to the negative fifth. Well, 8 divided by 4 is 2. So we're going to get 2 times, and then 10 to the third divided by 10 to the fifth. If we're dividing with terms with the same base, then we subtract the exponents. So negative 3, we would have 10 to the power of negative 3 minus negative 5, which is the same as negative 3 plus 5. And negative 3 plus 5 is 2. So, and 2 times 10 to the second power is 200. So yeah, this number is 200 times as much as this one. Okay, and we know that because when I take this one and divide it by this, I get 200, meaning that this number fits inside of this number 200 times. Okay, so let's click that one. Is 2 times 10 to the sixth 50 times as much as 4 times 10 to the fourth? So all of these are division problems here, so let's just do them quickly. So 2 times 10 to the sixth divided by 4 times 10 to the fourth. That's going to be, careful, this is 2 divided by 4, not 4 divided by 2. So 2 divided by 4 is a half, or 0.5. So I'm going to get 0.5 times 10 to the second power, because 6 minus 4 is 2. And 0.5 times 10 to the second power, if I do 1, 2, move that 2 spaces to the right, I do get 50. So yeah, this is correct also. What about this one? We're going to do 3 times 10 to the negative second divided by 3 times 10 to the negative third. 3 divided by 3 is 1. 10, and then negative 2 minus negative 3 is like negative 2 plus 3, which is positive 1. So we get 1 times 10 to the first, which is just like 1 times 10, which is 10. Okay, so this is incorrect. 0.1 is actually, this is the same thing as 10 to the negative first power. If it had said 10 to the negative first power, or 1 times 10 to the negative first power, then this would be correct. But we got 1 times 10 to the positive first power, which is just 10. So that's wrong. We're not going to click on that one. 6 times 10 to the fourth divided by 3 times 10 to the second. 6 divided by 3 is 2 times, again, 4 minus 2 is 2. We're getting a lot of 2's here for the exponents. That's just a coincidence. And then 2 times 10 to the second is 200, right? We're going to take this decimal point, move it 2 spaces to the right, put blanks in the zeros in the blank spaces. That would give us 200 over there. Not 2, so we're not going to click on that either. Okay, oh boy. A light year is the distance that light can travel in 1 year. That's right. A light year is a measure of distance, not time. A lot of people think that it's a measure of time because it's got the word year in there. It's actually the distance that light can travel in 1 year. So if you clicked on a flashlight and just let that light that came out of the flashlight keep going for an entire year, then the distance that it travels is called the light year. The Andromeda Galaxy, 2.5 times 10 to the sixth light years away from Earth, is the brightest galaxy that can be seen with the naked eye. The closest galaxy to Earth is the Canis Major Dwarf Galaxy. Okay, cool. I didn't know that. Though it is only about 2.5 times 10 to the fourth light years away, it can only be seen with a telescope. So yeah, this number is smaller than this number, which means that this galaxy over here is closer to the Earth than this one. But both galaxies are still ridiculously far away. You wouldn't try to walk over there. Use these numbers to complete the sentence below. Write your answer in standard form without using exponents. Standard form, remember, that just means the way that you normally write numbers, the way that you've been writing numbers ever since kindergarten, not in scientific notation. The Canis Major Dwarf Galaxy is about blank times as far away as the Andromeda Galaxy. Okay, so what we're going to do here is, again, if we want to know how many times further away one thing is than another, we're going to divide this one by this one. All right, so we're going to take the distance for the Canis Major Dwarf Galaxy, which is 2.5 times 10 to the fourth, and we're going to divide that by the number for the distance between Earth and the Andromeda Galaxy, which is 2.5 times 10 to the sixth. Okay. So we're going to get a fraction here, but we're going to write it in scientific notation so it won't look like a fraction. But the point is we're going to get a number which is less than 1 because the Canis Major Dwarf Galaxy is actually closer to Earth than the Andromeda Galaxy. So if I take so this number is actually smaller than this one. So if I take a number which is smaller and divide it by a number which is bigger, then we'll get an answer which is less than 1. In scientific notation, that would mean that we're going to have something times 10 to the some negative exponent. So anyway, let's figure out what that is. 2.5 divided by 2.5 is just 1. Anything divided by itself is 1. So we're going to have 1 times 10 to the fourth divided by 10 to the sixth. We're going to get 10 to the power of negative 2 because 4 minus 6 is negative 2. Careful. 6 minus 4 is positive 2, but 4 minus 6 is negative 2. Okay. I'm assuming they want me to write this in oh, no, no, no. They want me to just write it as a decimal. It's not giving me any options to put exponents in there. So what we're going to do now is we're going to take this decimal point over here, which is kind of invisible, and now we just made it visible by putting it at the end of the number. And we're going to move it 2 spaces to the left. So if we do that, 1, 2, we would get point, and then we'd put a 0 in the blank space, 1. And we can put a 0 in front also. So the Canis Major Dwarf Galaxy is about 0.01 times as far away as the Andromeda Galaxy, which actually means that it's closer than the Andromeda Galaxy, closer to the Earth. Okay, so that was a fun one. Next one. What is the value of this expression? Okay, so now we are adding numbers in scientific notation. And this one, let's put this in scientific notation. We'll do that a little later. First of all, if I'm adding numbers in scientific notation, just like adding fractions or decimals, you always want to make sure that you're adding the same kind of thing. All right, so we cannot add these together yet because this is times 10 to the negative fourth and this is times 10 to the negative fifth. So they're not the same kind of thing. So what we need to do here is take one of these numbers and rewrite it so that this exponent here is the same as the other number. And we can choose either one. I'm going to take this one, which is actually the smaller, the larger number because negative 4 is larger than negative 5. I'm going to take that and I'm going to figure out what this number would look like if I changed that negative 4 to a negative 5. So in order to do that, I had to actually decrease the exponent by 1. Okay, -4 minus 1 is -5. And when you decrease an exponent, you have to move the decimal to the right by however many times you decreased it. So we just decreased it by 1, so we'll move the decimal point 1 space to the right, and now it would be here, and we would have 12.5 times 10 to the -5th. Okay, and you can check if you want that these two numbers are actually the same. If I take this decimal here and I move it 5 spaces to the left, 1, 2, 3, 4, 5, you get 0.000125. If you take this decimal and move it 4 spaces to the left, 1, 2, 3, 4, what do you get? You get 0.000125 again. Okay, the decimal is not there anymore. It's over here. So yeah, both these numbers are actually the same. And what was the point of doing that? The point of doing that is so that now this exponent is the same as this one. So now I can rewrite the problem as 1.25 times 10 to the -4th. Oops, sorry. That's not what I wanted to do. I want to rewrite it as 12.5 times 10 to the -5th plus 7.5 times 10 to the -5th. Okay. And while we're at it, let's just convert this into scientific notation as well. 0.08 is the same thing as 8 times 10 to the -2nd. If there's a decimal here and we move it 2 spaces to the left, 1, 2, we get 0.08, same thing as over here. Okay, so this and this are really the same. We're just going to write that in scientific notation now because we're going to be doing that eventually anyway. Okay, so let's go ahead and add these two things together. So 12.5 plus 7.5, what is that? Let's work that out on the side. 12.5 plus 7.5. 5 plus 5 is 10. 0, carry the 1. 1 plus 2 is 3. Plus 7 is 10. Again, 0, carry the 1. 1 plus 1 is 2. Keep the decimal in the same place. So this is going to be 20. I don't need to really write the 0.0. 20 times 10 to the -5th power divided by 8 times 10 to the -2nd power. Okay, what's that going to be equal to? Let's do the easy part. -5 minus -2 is like -5 plus 2, which is -3. So I know I'm going to have something times 10 to the power of -3. What's 20 divided by 8? Let's work that out. 20 divided by 8. 8 does not go into 20. 8 times 0 times 8 is 0. 8 goes, whoops. Well, 8 does not go into 2. Now, 8, sorry, I said 8 does not go into 20. I meant 8 does not go into 2. Okay, now how many times does 8 go into 20? It goes into 22 times. 2 times 8 is 16. 20 minus 16 is 4. Decimal, decimal, bring down a 0. 8 goes into 45 times. 5 times 8 is 40. Subtract 0. We're done. Okay, so we're going to get 2.5 times 10 to the 3rd. Yeah, so we're done with the problem. That's the answer. And there we go. Okay. The fastest growing plant in the world is a species of bamboo. Cool. It can grow up to 3.5 times 10 to the 1st inches per day. All right. Complete the well, that's just 35, right? 3.5 times 10 to the 1st power is just 35. So it can grow up to 35 inches per day. Wow, that's a lot. That's almost 3 feet. So bamboo grows almost 3 feet every single day. That's cool. Complete the sentence. In one day, bamboo can grow about the length of... Oh, okay. I didn't even realize that was this kind of problem. Okay, so we should... This is kind of a weird problem, actually. Okay, so 3.5 times 10 to the 1st. We'll move this 1 space to the right, and we get 35. Okay. Let's just talk about some measurements. There are 12 inches in a foot. So 12 inches is equal to 1 foot. And there are 3 feet in a yard. So 3 feet is equal to 1 yard. If I wanted to know how many inches were in a yard, then what could I do? Well, I could say 1 yard is equal to 3 feet. So I want to know how many inches are in 3 feet. So I could do 3 feet times, I know that there are 12 inches in a foot, so times 12 inches per foot. These would actually cancel out here. Units cancel out in the same way that fractions do. So 3 feet, which is 1 yard, is equivalent to 3 times 12, which is 36 inches. So if I know that there are 12 inches in a foot and there are 3 feet in a yard, that means there are 36 inches in a yard. And that's pretty close to this 35 over here. Okay, so it said bamboo can grow 35 inches per day. That's almost a yard. So we can write here, in 1 day, bamboo can grow about the length of a yardstick. A yardstick is just a stick that's 1 yard long. Okay, so that's that. Let's continue here. Oh, another one of these. All right. Select all of the true statements. Okay, so we did this. If you don't remember, go back to the beginning of the video where we talked about why we should be dividing for these kinds of problems. So I'm just going to assume that you watched that. I'm going to divide here. 1 divided by 2 is 0.5 times, okay, so negative 2 times 10 to the negative 2 minus negative 4, because when we're dividing terms with the same base, we subtract the exponents. Negative 2 minus negative 4 is like negative 2 plus 4. Negative 2 plus 4 is positive 2. So we're going to get 0.5 times 10 to the second. In standard form, I'm going to move this 2 spaces to the right. Since that's a positive 2, I'll move it to the right. 1, 2, and that put a 0 in this blank space, and that would give me 50. So yeah, 1 times 10 to the negative second is 50 times as much as 2 times 10 to the negative fourth. Okay. I'm trying to decide right now in my head if I really want to finish this problem, because we already did one like it. I can't move on to the next level, but I'll do this one, and then if the next question turns out to be the same, then I'll just stop. The same as something we already did. So let's do 8 times 10 to the second divided by 4 times 10 to the fourth. That's going to give me 2 times 10 to the negative second power, because 2 minus 4 is negative 2, which is the same thing as 0.02. Just take this invisible decimal here and move it 2 spaces to the left, because that's negative, and we get 0.02, which is what I wrote over there. So yes, this is also true. All right, 3 times 10 to the negative sixth. Is that 6 times as much as 5 times 10 to the negative second power? Okay, 3 divided by 5 is 0.6. Negative 3 minus negative 2 is like negative 3 plus 2, which is negative 1. So 0.6 times 10 to the negative first power. No, because I have to, since that's negative, I would have to take this decimal point, move it 1 space to the left. That would give me 0.06, not 6. So this one's no good. 8 times 10 to the ninth is 2,000 times as much as 4 times 10 to the sixth. Yeah, that's correct. Let's just show it over here. 8 divided by 4 is 2. 9 minus 6 is 3. 2 times 10 to the third, 1, 2, 3. We're going to get 3 zeros there. Yeah, so that's 2,000. So that's right. Okay. Is this a different kind of problem than what we've done before? I guess so. An aquarium pumps filtered seawater from the bay into its exhibits. An aquarium pumps filtered seawater from the bay. Oh, that I was reading this as if it were a plural noun. It's a verb. Okay. An aquarium pumps filtered seawater from the bay into its exhibits at a rate of 1.2 times 10 to the fifth gallons per hour. How many gallons of seawater are pumped into the exhibits in a full day? Well, it's pumping this much every hour. I know that there are 24 hours in a day. So in order for me to figure out how much it's going to pump in a full day, I would have to take this number and multiply it by 24. So let's do that. 1.2 times 10 to the fifth times 24. Okay, that's going to give me something times 10 to the fifth. Okay, there are no other times 10 to the something terms over here that I could multiply with this one. So really what I'm doing here is I'm just rearranging this. We're going to do one, because we're just multiplying everything, so we can rearrange the order and it's still the same thing. So instead of doing this times this times this, I could do this times this times this. So I'm just going to get something times 10 to the fifth, okay, which is what I wrote over here. All right. So what's that something going to be? What's 1.2 times 24? Let's work that out. Okay, if we're multiplying, then we don't need to line up the decimals. 2 times 4 is 8. 2 times 2 is 4. I like to put an X here, or you could put a 0. 1 times 4 is 4. 1 times 2 is 2. Add them up. 8 plus 0 is 8. 4 plus 4 is 8. Nothing plus 2 is 2. And then there are no decimals here. This is one space over, so we'll do one space over here. 28.8 times 10 to the fifth. Write your answer in scientific notation. This is not in scientific notation because to be in scientific notation, it's got to be a number between 1 and 10 times 10 to some integer. Okay? A number between 1 and 10. It can be 1, but it has to be less than 10. So it can't be exactly 10. But anyway, this number over here is greater than 10. So that's not going to work. How can I make this number between 1 and 10? I would have to take this decimal here and move it one space to the left. But if I do that, if I move this one space to the left, then I would need to compensate for that by increasing this by 1. So I would get 2.88 times 10 to the sixth. And if you don't remember that rule, that if you move this to the left, you have to increase this. If you move this to the right, you have to decrease this. You might not remember that rule and you might make a mistake, but it's easy to check your answer. You know, is this the same as this? Well, let's check it. If I take this decimal and move it 6 spaces to the right, 1, 2, 3, 4, 5, 6, that would give me 2, 8, 8, and then these would all become zeros here. 0, 0, 0, 0. Is that the same as this one? So if I take this decimal and move it 5 spaces to the right, 1, 2, 3, 4, 5, then I would get 2, 8, 8, and then 1, 2, 3, 4 zeros. So yeah, this is the same as this, okay, which means that this number is the same as this number. It's just written in a different way. This one is written in proper scientific notation because now the coefficient is between 1 and 10. So let's write over here 2.88 times 10 to the sixth power. Okay. Hair grows at a rate of 5 times 10 to the negative second inches per month. That's pretty small. Whereas nails grow around 1 times 10 to the negative 2 inches per month. Use these numbers to complete the sentence below. Nails grow about blank times as fast as hair does. So when we see a problem like this, we're going to take the number for nails and we're going to divide it by the number for hair. We're not necessarily going to take the bigger number and divide it by the smaller number. We're not necessarily going to take the smaller number and divide it by the bigger number. We're going to take whatever number is associated with this word over here and divide it by whatever number is associated with this word over here. So nails, that was 1.10, whoops, what am I saying? 1 times 10 to the negative second. We're going to divide that by 5 times 10 to the negative second. 1 divided by 5 is 0.2. Okay, I don't mind if you use a calculator to do something like this. 1 divided by 5. You can punch that into a calculator. Then we have times 10 to the negative 2 minus negative 2. When anything subtracted by itself is going to be 0. Or you could just think of it that -2 minus -2 is like -2 plus 2, which is 0. Okay, so that, and 10 times 10 to the power of 0 is just 1. So 0.2 times 1 is just 0.2. So we're just going to write 0.2 over here. So nails grow about zero point 0.2 times as fast as hair does. Okay, which means that nails actually grow slower than hair, which makes sense because when you look at these numbers, both of them have the same exponent over here, -2, except this one is a 5 and this one is a 1. So yeah, this number is smaller than this number. So nails grow slower than hair. Okie doke. Let's continue. A building project costs 3 times 10 to the seventh dollars. How many millions of dollars is that? Oh, tricky. So, this is like asking a building project. This is as if the problem said 3 times 10 to the seventh is let's just do it like IXL does it, is blank times uh, as much as a million. 3 times 10 to the seventh is blank times as much as a million. In other words, how many millions can I fit inside of 3 times 10 to the seventh? So we're going to divide here like we have been doing for these types of problems. And we're going to say 3 times 10 to the seventh divided by, well, what's a million in scientific notation? Here's a million in standard form. What would that be in scientific notation? That would be 1 times 10 to the sixth power. Okay, and then 3 divided by 1 is 3, and 7 minus 6 is 1. So I'm going to get 3 times 10 to the first, which is just 30. Okay, so we're going to write 30 over here. All right, and let's see if that answer makes sense. So we're saying 30 million. Okay, so 3 times 10 to the seventh is 30 millions or $30 million. Okay, let's see if that makes sense. 30 million means 30 followed by 6 zeros. And this number is the same thing as 3 times 10 to the seventh, right? If the decimal is here and then we move it 7 spaces, 1, 2, 3, 4, 5, 6, 7, then yeah, we can see that this is the same as 30 million, right? Like we wrote over here. So there are 30 millions in 3 times 10 to the seventh. Okay, and let's submit that. In a laboratory, scientists can check the purity of an aspirin sample by determining its melting point. The melting point of pure aspirin is about 2.8 times 10 to the second degrees Fahrenheit. Complete the sentence. Aspirin melts around the temperature of... Oh, okay. All right. So, yeah, this is kind of a weird problem to ask. So 2.8 times 10 to the second. If I take this decimal here and I move it 2 spaces to the right, 1, 2, I get 280. Okay, 280, and that is degrees Fahrenheit. Okay, for those of you who come from a country where they measure heat in Celsius instead of Fahrenheit, which is most countries actually. We can go to a calculator to work that out. So you can just search for Fahrenheit to Celsius, and then we'll type in 280. And for those of you who think in terms of Celsius for temperature instead of Fahrenheit, you can think of this as about 138 degrees Celsius. So let's go back here and say, if you want to think in terms of Fahrenheit, you could think of it like this, or if you prefer thinking in terms of Celsius, it would be approximately 138 degrees Celsius there. Okay, so is this the temperature of the human body? No. If you're healthy, then your body should be about 98.6 degrees Fahrenheit. Or in let's do that in Celsius also. What's 98.6 degrees in Celsius? That would be about 37 degrees. So this is not the temperature of the human body. Is it the temperature of an ice cream cone? No way. No ice cream cone is 280 degrees Fahrenheit. That it would melt, right? Is it the temperature of a cup of hot chocolate? It's probably even too hot for a cup of hot chocolate. This is really hot. This would scald your tongue if you tried drinking hot chocolate at this temperature. So, no. Is it the temperature of a warm oven? Yeah, you might set your oven to 280 degrees Fahrenheit if you were cooking something. So, yeah, that seems to be the best way to complete this sentence over here. So, aspirin melts around the temperature of a warm oven. Okay, that's interesting. I never really had any need to melt aspirin, but I suppose if I wanted to, now I know how. Okay. A giraffe heart. Wait, wow, these are getting really. Okay, a giraffe heart weighs about 4 times 10 to the second ounces. For comparison, a human heart weighs about 1 times 10 to the first ounces. Using these numbers to complete the sentence below. Use these numbers to complete the sentence below. Write your answer in standard form without using exponents. A giraffe heart weighs about blank times as much as a human heart. Okay, so I think we've done plenty of problems like this. We would just take the number for giraffe, which is this one, and divide it by the number for the weight of the human heart, which is this one. Seriously? Oh, 10. That a human heart only weighs 1 times 10 to the first is just 10, actually. A human heart only weighs 10 ounces, really? I thought it was heavier than that. Oh, that's interesting. Okay, but anyway, we've done a whole bunch of problems like this before, so we would just divide these two numbers. So I think I'm going to end the video there. Hope that was helpful, and have a great day.